All right, so graphing the complex numbers, if we want to graph 2 plus 3i, think of it as the ordered pair 2 comma 3. So we start at the origin, we go 2 to the right and 3 up, and that's 2 plus 3i. B would be negative 1 plus 1i, that would be like negative 1 comma 1, because there's really a 1i there. We start at the origin, we go left 1, up 1, and then 4 minus 2i would be like 4 negative 2, so we go 4 to the right, down 2. And then if it's negative 4i, that would be like 0 comma negative 4. So we start at the origin and we just go down 4. That's considered a pure imaginary number. Operations with complex numbers are just like operations with anything with an x. You just basically collect like terms and simplify. So 3 plus 6 is 9. And then 2i plus 5i is 7i. So we just collect like terms. Here we have to distribute the minus to both of them here. So we get negative 4 plus i. So negative 2 minus 4 is negative 6. And then 3i plus I is positive 4i. Like that. Here we have to FOIL it out because we're multiplying. So we got 4 times 5, which is 20. 4 times negative I, which is minus 4i. 2i times 5 is 10i. And then 2i times negative I is minus 2i squared. So the only thing we need to remember to do here is if we have I squared, that's the same as negative 1, right? And that means we're going to change this to a negative 1. So we end up with 20 minus 4i plus 10i. It's going to be plus 6i. And then we end up with minus 2 times negative 1, which is like a plus 2. So we have 20 plus 6i plus 2. We end up with 22 plus 6i for that. If we're dividing by I, it's similar to the idea that we can't have a square root on the bottom of a fraction. We have to rationalize that. So like here, we would multiply the top and bottom by root 5 and get 3 root 5 over 5. Same thing here. So we're going to multiply both the top and the bottom by I, and we get 6i all over 2i squared, which is like 6i over, again, this becomes negative 1. So 2 times negative 1, so that gives us 6i over negative 2, which is negative 3i. If we end up with 1 minus I, we have to multiply both the top and the bottom by the conjugate. So we change that symbol to its opposite, which is 1 plus I. And then that's going to equal, distribute the 4. 4 plus 4i. Here we got to FOIL that out. 1 times 1 is 1. I plus negative I cancel, so you get minus I squared, which is 4 plus 4i. All over 1 minus negative 1. 4 plus 4i over 2. And then 2 goes into 4 twice, 2 goes into 4 twice, 2 goes into 2 once. So we end up with 2 plus 2i over 1 is just 2 plus 2i. And the last thing is the powers of I. So I squared is going to be negative 1. I to the third is going to be negative 1 times I, so that's negative I. I to the fourth is going to be 1, because we get I squared times I squared. So here we have I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth. And we're just going to repeat that cycle. So we're always going to start here. Okay, so if we want to find I to the seventh, you start here, I to the first, I to the second, I to the third, I to the fourth, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's just I. I to the 32nd, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 5, 6, 7, 28, 29, 30, 31, 32. It's just going to be 1. And you can start to see patterns there too. Like it just repeats in cycles of 4. So I to the first, I to the second, I to the third, I to the fourth, I to the fifth. So if you divide 4 to the number, you can take the remainder and you know where you're supposed to be. Or you can just go around the cycle.